what you'll hear about is how our technology can make LLM networks much more reliable and also much faster. Okay? So the problems are, there's a path like this, it's a queue pair, and it's possible that an internal link fails, or it's possible the edge link fails. And in both cases, what we'll do is find an alternate path to route the traffic around the broken path. Okay? And what do the results look like? Again, this is on OCI. And so we have a 4-server cluster, 2 servers per rack, 2 racks. And what you'll see is a job that runs on these nodes, and it's going from one node to another node across the rack, so it's touching the spine layer. And the 3 cases are basically where there's no failure. This is status quo, right, on the left. And second one is where we don't have our solution, but the NIC fails. So at the point where the NIC fails is indicated on the graph, the job also dies. And when the NIC is revived, the job stays dead. The job isn't reviving. Okay, so this is pretty canonical. This happens, in the course of operation of these networks where the edge link fails. On the other hand, when you have our solution on, this is again this piece of software, if the edge link fails as shown the same place, the job continues to work at pretty much close to the previous high throughput, okay? Because we found some good alternate paths, and these are supporting the traffic of the failed NIC. And then when the original NIC revives, and this happens because, again, these links go on the blink. They're not like gone forever. So that when this hot lasers on either side, and the temperatures, the bit boundaries are lost, they're reestablished. And when the reestablishing happens, the NIC comes back. The link comes back. As I said before, there are 2 nodes two pairs of nodes communicating, and the green and the brown or orange queue pairs end up meeting at a link in the network. As indicated, the flows are contending for the bandwidth on that downlink from spine to top of the rack, right? And this is happening all the time in this network. Okay, so the first of the 3, 2 all reduced jobs. The first one starts, gets 91 gigabits per second. There could be a small amount of contention already with just one job, right? Because it's only half the bandwidth used, but then it's just ECMP. Could be unluckily getting some of these guys colliding. But let's go to the bottom. When only one job is on, you can see the one-way delays that we're able to measure are very small. This says there's not much contention going on. Okay? If anything, it'll be something so negligible that it's not even worth addressing. But as soon as the second one starts, not only is the bandwidth, it's bringing down the first because they're both contending now. This is like the green and the orange guys, they're hitting each other. You can see the delays have gone up, right, immediately. And these delays are, a few tens of microseconds. Now, because we detected that, and we turn on the control, very quickly you can bring up the bandwidth, and the one-way delays are brought down, right? So this is sort of the bottom part is how the measurement of or detection of congestion is being done. And the top is what the remedy looks like. Okay, so
it's a good day when you have a problem and a startup comes along and promises to solve the problem. That's a lucky day. So I'm personally at a personal engineer level. I'm really excited to be working or collaborating with Balaji and team, and I have high hopes for future. Because I'm a technology guy, and I like technology because I think it's a powerful weapon for solving problems. Weapon is the wrong word, tool for solving problems. And hopefully this is that. And I'll make a couple other observations. Balaji and Vinay made it sound like a really simple thing to solve. This is not a simple problem to solve. I'm sure everybody in the room can appreciate how hard these problems are. These are not at all easy problems. Anybody who understands networking realizes these are hard problems. All cloud providers, all infrastructure teams in the industry have these problems. Those that claim they don't are either guilty, these are my words, guilty of lying or not paying attention. Everyone have these problems. I have a talk later today at 2:45 with Pradeep Vincent, where we will describe some of these problems. So these are really interesting, important problems to solve. This is really good work. I think this is great stuff. And by the way, Balaji, his work lies at the bottom, at the very foundation of congestion control for Rocky in the form of QCN and DCQCN. So I'm glad he's come back to put the cherry on the top. But yeah, I think this is great work. Thank you. Yeah.